Okay, for a practical problem on quadratics, we're going to calculate the gravitational constant here on Earth. Go to your unit here, and it says TSW5, and here's the application. 104 kinematic equations, and then a few videos, and then we're going to calculate the acceleration due to gravity. So on the first link, following this one, goes here. And what we're seeing is the kinematic equations for motion. In this case, the constant acceleration is gravity. So when we use these things, we'll use the displacement in the vertical direction, time, initial velocity, final velocity, and then constant of acceleration. In this case, for Earth, we know what it is, but we're going to calculate it based on the measurements we're making. There's four equations that apply to these motions. So the velocity at any time is equal to the initial velocity plus the acceleration times time. We're assuming that the acceleration is constant. And another kinematic equation is the change in distance. How much distance is covered is equal to what works out to be the average velocity times time. And the third one, the distance is equal to the initial velocity times time plus 1/2 of the acceleration due to gravity times t squared. And the final one is velocity at any time is squared is equal to the initial velocity squared plus 2 times the acceleration times the distance covered. Now, of these, which ones are quadratic? This one has a t and a t squared. This one is quadratic. So it has a constant, like a c term, and this would be the b, and this would be the coefficient a. Coincidentally, this a is also the acceleration due to gravity. So let's work this out in what we need for this equation. We're going to find the information. We're going to find the distance covered, and we're going to find the initial velocity and how much time. And that time is here, and it's also repeated here. So once we have all of those, the only thing left is that A, acceleration due to gravity. So how will we find it? Let's throw a ball up in the air. Okay, so we go back to our assignment and look at this video here. This is a video done at full speed. So this is the video here, taken at full speed. And rises and he catches it. So it's thrown up, comes back down. But you'll notice on our kinematic equations, what did we have? We had initial velocity. That's going to be critical. Let's work with that. We had on our kinematic equations, we had the initial velocity. Now, I don't know how fast he threw it, but what is the velocity at the very peak, the very top? How much is the vertical velocity, up, down velocity? It's 0. So this would be 0. So let's keep going with that information. And so we measure from the top, and I'll show you this one. We'll measure from the top. We'll measure from the top and have this ball go to the top. And when it's at the top, the upward and downward velocity is 0. So its initial velocity upward is 0. And then as it comes back down, it will have a certain amount of distance it covers from here to here. And it will also have a certain amount of time that transpires. So let's take it up to the top and I'll describe this to you. I'm going slow. Notice this video is at 1/4 speed. So the ball is going up, 1/4 speed on the video so you can see it. The ball is not really obvious, but you'll see it. And right about there. So let's go a little bit further. Right there, paused right there. That's pretty much the top. So we're at what reads to be 5 seconds. But of course, this is 1/4 speed, 5 seconds in the video. And it goes from this height, and we're going to stop right about here. So That's a certain distance. Let's play it. Goes down, and we'll stop right when he catches it, right there. Okay, so right about there. And what second is that? That looks like 10. So let's say that it went that 5 seconds. But it's not 5 seconds, it's 5 seconds in the video. But what is 1/4 speed? What does that mean? I'll let you work that out. Last thing you need is that distance, right? So on here, you also have one last link. It's to a picture that says it's 4.5 meters across on the sign. So if it's 4.5 meters across here, and the pictures of the students is not skewed wide or tall, then we can assume that the same distance is covered from here to here, same scale. So it's 4.5 this way, it'd be 4.5 at some point, but then of course the ball goes from here to here. So you have to say, okay, how far is that? You can even take a measure off of the screen, something that gives you some idea how far this point is to when he catches it. Okay, so back to our equations. We'll use that information. We'll put in the distance. Initial velocity was how much? 0. Time off of the screen, off of the time stamp on the video. How far did it go? And then the last variable, of course, is the one we're solving for. So you solve for that algebraically. And you have the calculation you determine as the acceleration due to gravity on Earth.